Okay, today's topic is units and standards. So standard indicates the physical representation and unit represents the material representation. So if you observe the basic fundamental physical quantities like mass, length, time, electric current, temperature, amount of substance and luminous intensity, each fundamental physical quantity is having its own unit. So if you take the mass, the unit for mass is kilogram. So all these units are according to international standards. Coming to the definition of kilogram, so we can define the kilogram as a 1 cubic decimeter of water at 4 degrees centigrade temperature at its maximum density. Then the weight of the water can be taken as the kilogram. So here 1 cubic decimeter of water is going to be taken as the taken as the physical representation. So based upon the weight of this 1 cubic decimeter of water, a platinum iridium cylinder of prototype is going to be designed. So this represents the material representation. So physical representation gives the standard and the material representation gives the unit. So similarly, international standards or International Bureau of Weights and Measures is giving their own physical representation and material representation for the units of the remaining fundamental physical quantities for meter, for second, ampere, Kelvin, mole and candle. So coming to supplementary units, so supplementary units are of two types, plane angle and solid angle. So plane angle units are radians and solid angle units are steradian. So the basic difference between the plane angle and solid angle is, so if you come to the plane angle, so it is the angle which is used in the two-dimensional view. So two-dimensional view means the image is going to be varying with respect to x-axis as well as y-axis. So if you come to the solid angle, so it is the angle which is going to be indicated when the image is going to be moving in the three-dimensional view. Suppose if the image is moving according to x, y and z axis, if you want to represent the angle in the three-dimensional view, we can use the steradian. So these are also the supplementary units. So according to International Bureau of Weights and Measures, they were going to be giving the physical representation and material representation for these supplementary units also. So coming to standards for mass, length and volume. So we discussed about the physical and material representation of mass, that is kilogram. So in some countries the units for the mass can be taken as the pounds. So according to Weights and Measures Act of 1963, the pound can be defined as it is equal to 0.4535923637 kilograms exactly. So the standard for 1 meter is the distance that light travels in the vacuum for 1 by 299,792,458 seconds. So that is, so we can define the meter as in a vacuum when the light is going to be propagating for 1 by the fraction of the second, 299,792,458 seconds. Then what is the distance travelled by the light? So that distance can be taken as the meter. So in some cases, in the place of the meter, we can use yards or inches for measuring the length. So the yard is defined as 0.9144 meters and 1 inch can be defined as 25.4 mm exactly. So coming to the working standards, so these working standards are usually in our day-to-day activities or in our laboratories. So if you want to measure the length, the working standards which are used are the precision gauge blocks. So block means just it will be in the form of a brick. So where we are going to be using the bricks in our construction, home construction. So similarly, in the form of the bricks only, we are going to be placing one steel blocks. So each block is having its own length. The length of the blocks will be different here. Suppose if you want to measure the 100 meters length, we are going to be using a large number of precision steel gauge blocks by placing the precision steel gauge blocks according to the length of the 100 meters, and then counting the length of all these precision steel gauge blocks, we can know or determine the length of the particular physical quantity. Okay. So here the working standard which is used for measuring the length here is precision steel gauge blocks. So coming to the unit of volume, so this volume comes under the category of derived unit. So the volume can be represented as length into breadth into height. So here the length, breadth and the height, all these three parameters comes under the category of length fundamental physical quantity. Coming to time standards and frequency standards. So time standard. So nowadays we are going to be measuring the time by using digital clocks or analog clocks. So in olden days it is very difficult to measure the time. So they were going to be finding the time based upon the position of the sun in the sky. So here the position of the sun is going to be changing. Okay. So according to the position of the sun, they were going to be determining the time. So how the position of the sun is going to be changing? That is, according to solar system, the earth is going to be moving its own axis around the sun. The earth is going to be moving its own axis around the sun. So whenever the earth completes one So whenever the earth completes one revolution around the sun, it indicates 1 year of completion. So whenever the earth completes one rotation around itself, it indicates 1 day completion. So according to the position of the earth around the sun, the position of the sun is going to be changing. So according to this, in olden days we are going to be determining the time. So this time indicates the mean solar time, or it is also called as universal time. So the mean solar time or the universal time is also defined as the rotation of the earth around the sun. So this universal time or mean solar time will be having some drawbacks. So we can overcome those drawbacks by using the another notation that is called as the feminist time. So it is based upon the rotation of the moon around the earth. So based upon the rotation of the moon around the earth, we are going to be determining the time. Okay. So here this universal time is going to be classified into two types, UT1 and UT2. UT indicates universal time 1 and universal time 2. So the drawbacks which are going to be occurred in this universal time are, so here when the earth is going to be revolving around the sun, so we are going to be getting different seasons. So winter, summer and rainy season. So if we take the case of a winter season, so at the North Pole we will be having the large amount of ice blocks. So in winter season we will be having the ice blocks. So if you come to the summer, all these ice blocks are going to be melted and then we will be getting some water around the surface of the earth. So in this case, the mass will be distributed around the surface of the earth. So as the mass is going to be distributed around the surface of the earth, then we will be getting some amount of changes in the movement of inertia of the earth. So as all of you know, movement of inertia means the inability of movement. So due to the change in the mass distribution on the earth will be changing its inability to move around the sun. As a result, the speed of rotation of the earth around the sun will be changing. So ultimately, the time parameter is going to be changed. So these are the main drawbacks which are going to be occurred in the universal time or mean solar time. So in order to overcome these drawbacks, they had gone to feminist time, that is called as the ET time. It is one standard. So this standard is going to be based upon the movement of the moon around the earth. So it is also having some drawbacks. That is, it will, if you want to make this time to be calibrated, it will be very difficult. So we cannot perform the calibration of this time frequently, because in this ET standard, the moon should come in between the sun and the earth. Then only we can perform the calibration process. So in order to get the moon in between the sun and the earth, it will take some few years or some few decades also. So if you want to use any standard, first of all you have to perform the calibration frequently. Then only the standard will be good for taking the measurement purpose. So here in ET standard, the main drawback is the calibration process cannot be done frequently. Okay. So these are the main drawbacks in UT or mean solar time and ET standard. ET standard time measurement. So in order to overcome all these drawbacks, so finally one equation is going to be obtained, that is h mu is equal to E2 minus E1, where h is called as the Planck's constant and mu is called as the frequency. E2 and E1 are called as the energy levels. So how we are going to be getting this equation means, so just you take the cesium atom. So in the cesium atom, as all of you know that in an atom we will be having the nucleus. Around the nucleus all the electrons are going to be revolving. So within the nucleus we will be having the protons and the neutrons. So in the cesium atom we will be having large number of orbits. So each orbit is having its own energy level. So generally the outer orbit will be having the higher energy level and the inner orbits will be having the lower energy level. So whenever the electrons are going to be jumping from the higher energy level to the lower energy level, some of the light is going to be emitted. So we are going to be getting the, that is we are going to be determining the frequency of that light. So that frequency can be indicated using this equation. So here h mu indicates the frequency of the light which is going to be emitted when the electrons are going to be jumped from the outermost orbit to the innermost orbit. So that frequency is equal to E2 minus E1. So E1 is the energy level of the inner orbit and E2 is the energy level of the outer orbit. So whenever the electron is going to be jumping from the third orbit to the first orbit, then the energy level of the third orbit is subtracted from the energy level of the first orbit. Then we are going to be getting that energy level. So that energy level is having some frequency. That frequency is called as h mu. Okay. So here the transition between two energy levels E1 and E2 of an atom is accompanied by the emission or absorption of radiation having a frequency given by h mu is equal to E2 minus E1, where h is called as the Planck's constant. So if we get the frequency, then we can easily find out the time, as the time and frequency are both are inversely proportional to each other. Okay. So from this we are going to be defining the time, that is 1 second. So this is the final definition which is given by the International Bureau of Weights and Measures. That is 1 second can be defined as the transition between two energy levels E1 and E2, and we are going to be getting some amount of radiation. That frequency of that radiation is going to be measured by using h mu is equal to E2 minus E1. After getting the frequency, we can find out the time, as t is inversely proportional to frequency. So the electrical standards are the absolute ampere, resistance standards, voltage standards, capacitance standards and inductance standards. So all these standards comes under the category of electrical standards. Okay. So in the previous class we had seen about what are the different standards of measurement. So basically these standards are going to be classified into 4 types: international standards, primary standards, secondary standards and working standards. So these international standards are going to be defined by international agreement, and these are maintained by the International Bureau of Weights and Measures in Paris. So these are the topmost standards, and the remaining 3 standards are going to be calibrated with respect to international standards only. Okay. So these we are having some amount of committees according to these standards, like International Bureau of Weights and Measures. Okay, coming to primary standards, so these are the standards which are going to be maintained by the each country in the world. So if you come to the India, the national, these primary standards are going to be maintained by National Physical Laboratory, NPL, so which is going to be placed in the Delhi in India. So if you go to America, so these primary standards are going to be maintained by NBS, National Bureau of Standards. So in this way, each country is having their own committees in order to maintain the primary standards. So, but these primary standards should be frequently calibrated with respect to international standards before using for the measurement purpose. Coming to secondary standards, so these are the standards which are maintained in the calibration laboratories and in the industries while we are going to be performing the measurement purpose. Okay. So coming to working standards, and these are the working standards is working where we are going to be using all these standards for the purpose of the measurement, like in our laboratories. So if you go to the length measurement only, so if you want to measure the length, we can use the precision gauge blocks as the working standards for the measurement of the length. Okay, thank you.